Hello.
Hello.
I think we completed till fundamental theorem of arithmetic. Na? What does it mean?
Fundamental theorem of arithmetic means every number can be expressed as product of prime and factor.
Every composite number, not every number. Every composite number we can write as the product of a prime number. Product of a
Prime number.
prime number. And this is how we find by one method called prime factorization. Called prime
Factorization.
prime factorization means divide the given composite number
Composite number by prime number.
by prime number. So I can write 25 as the multiply product of a 5 into 5 or 5 square. Okay. I think we completed this. Then okay. Come to one important question. Example 1. Look the question. Example 1. Question number. Example 1. Consider the numbers 4n. This is 4n or 4 to the power n. Okay, look. This is 4 to the power n. Okay. Where n is a natural number. Okay. Where n is a
Natural number.
natural number. Try to understand this question. You have one question that you have one number that is written in 4 to the power n. 4 to the power means 414, 42. N is a natural number means n can be 1, 2, 3, dot dot dot. Okay.
4, 5, 6, 7, 8.
Check whether there is any value of n for which 4 raised to the power n ends with the digit 0. Means the question is asking you find the condition. Are there any condition, are there any value of n that the 4 raised to the power n ends with the digit 0? Is it possible? Okay. Before going to these things, let's study one concept called cyclicity. Cyclicity. Cyclicity of a number. Okay. Cyclicity of a number. Okay. First the number is first I'm taking the number as 5. Tell me 5 raised to the power 1 is how much?
5.
5 raised to the power 2.
25.
5 raised to the power 3.
125.
5 raised to the power 4. 625. The question is look the cyclicity. Look the cyclicity means unit digit. Always ends with the digit 5. So someone asked the question 5 raised to the power 1021. What is the unit digit? What is the unit digit? Ends with means unit digit. Look the cyclicity. Look the cyclicity. Always 5 na? So that means 5 raised to the power 10, 1021 maybe must be end with 5 na? So this is called unit digit 5. This is the cyclicity of a 5. Okay. Then move to 6. Cyclicity of a 1. You can look 1. 1 square how much? 1. 11 square 121. 111 square same thing ends with the digit 1. 2 square look 2 square 2. 2 square. So that means I can say cyclicity of 1 is 1. That means end with the digit 1. Okay. 2 2 2 to the power 1 2 2 square 4 2 sorry 2 power 1 it's 2 2 power 2 4 2 power q 8 2 power 4 16 2 power 5 32 2 power 6 64. Look after some time the digit are repeating. After some time the digit are repeating. Are you looking? Means the cyclicity is 4 means divide the power by 4. If it is 1 then answer will be 2 or 5 2 power 1000. Okay. 1021 divided by 4. Divide this 1021 by 4. Then look the remainder. Look the remainder. If 1 then 2. If 2 4. Okay. Then move to that means check the cyclicity of a 4. Cyclicity of a 4. 4 to the power 1. 4 raised to the power 1. 4 raised to the power 2.
16.
4 raised to the power 3. 4 raised to the power 4. 256. Look for even, for odd end with 4. For even end with 6. Then think. Your question is asking 4 raised to the power n. Look, are you thinking are there any value of n that end with 0? Because cyclicity is look once 4 then 6. Then how is it possible for 4 raised to the power n and the value of n ends with 0? Is it possible?
No.
No, because look na. Then 4 raised to the power 5 it should be end with 4. 4 raised to the power 6 it must be end with 6. Then there will be no value of n that ends with 0. That ends with 0. Actually, how you gave the answer? Write on the answer. Otherwise, after watching the video, you can write the answer. Okay? Look. I'm taking one example 10. I'm taking one example 10. If I prime factorize this 10, it should be 2 into 5 na?
2 into 5.
Then 20. 2 into 2 into 5. 5.
2 into 5.
100. 2 into 5 into 5.
5 into 5.
1000. 2 into
5 into 5 थोड़ी ना होगा 100 का.
5 into 5 25. 25 into 2 into 2. Okay. 100 into 10. 100 into 10. 5 into 2. This is for 1000. Okay. That means can I conclude any number that end with 0? If I do that number prime factorization, there should be 2 and 5. Both should be there. Otherwise, look, any number in the world that end with 0, in their prime factorization, there should be 2 and 5 available. Okay, you understand? So if I prime factorize 4, because it is 4 power n, na, then I will get 2 square. Here 5 is 5 is missing. Here 5 is missing. So I can write the answer like this. You understand? Any number that end with 0 in their prime factorization, there should be 2 and 5. Okay? There should be the prime number 2 and 5 in their prime factorization. But it is not possible in 4 raised to the power n. So I can write the answer as we know that a number end with the digit 0, end with the digit 0, contains 2 and 5 their prime factor. 2 and 5 their prime factors. Look, we know that a number ends with the digit 0 contain 2 and 5 their prime factors. But 4 raised to the power n, whose prime factorization is 2 into 2 raised to the power n, only 2 are there, prime factor, 2 are their prime factor. So 5 is missing in the factor. 5 is not available. 5 is not available. 100% this type of a question will come in your exam. Okay, you understand the concept how to write, only focus. We know that a number end with the digit 0 must contain 2 and 5 their prime factor. But in 4 raised to the power n, which prime factorization is 2 into 2 raised to the power n, only contain 2 as the prime factor. 5 is not available. So therefore 4 raised to the power n never end with digit 0. Never ends with digit 0. You understand this concept? This is such a important and directly question will comes like this. Instead of 4 raised to the power n, they will give 8 raised to the power n. Okay, you have to write same thing. You understand the concept? Read the example number 2.
Find LCM and HCF of 6 and 20 by prime factorization.
Okay. That means that is such an important concept. It is also 2-mark question. Okay, 2 or I think 3-mark question. How to find HCF and LCM by prime factorization method. Look, there are various methods for finding LCM and HCF. Okay, like log division method, like here one prime factorization method, then by finding factor method. Okay, so look, I am doing this. Tell me. Okay, instead of a 6 and 20, I am finding 32 and 12. Okay, tell me, what are the factors of 32? You have to do prime factorization, na? You know na prime factorization? 16, then 2, 8, 2, 2, 2. How many 2 are there? 2 into 2, 4, 4 into 2, 8, 8 into 2, 16, 16 into Okay, I can write 32 as 2 raised to the
2
power
to the
5.
power 5.
2 raised to the power 5. Then 12, 6, again 2, 3.
2, 3. 2 raised
12,
to the power 2 and 3.
3. Look,
पावर
after
2 होगा ना उधर?
hmm?
2 की पावर 2.
Hmm. Then after finding prime factorization, how to find LCM? Okay, LCM means lowest common multiple. But here you have to find highest factor, highest power, highest power.
हाँ.
Okay, look here. First look here. 2 raised to the power 5 means base 2 is there. Here also base 2 is there, na?
हम्म.
Here 3 is there, but here 3 is missing, na?
हम्म.
Then write out 3 raised to the power 0. The term which is unavailable in both the cases. In suppose 3 is available in the factor of 12, but it is unavailable in the factor of 32, na?
हाँ.
Are 3 raised to the power means 0 means how much? 1, na? Okay,
हम्म.
so I write this. Then look, look here 2, 2. Both the cases 2 is available, na?
हम्म.
You have to take the larger part. You have to take the highest part for LCM or LCM.
LCM.
Then for 3, this is the highest power, na?
हाँ.
Then 32 into 3, 32 into 3, 3 2 ja 6, 3 3 ja 96. You understand how to find?
हाँ.
First, find the factor by prime factorization method. Sorry,
2 raised to
find
the power 5.
convert the composite number as the product of a prime number. After finding the after finding the prime factorization, then look which term is missing. Here 2 2 is present, here 3, here 3 is missing. So write down 3 raised to the power 0. Then for LCM, look the each term highest power. Okay,
हम्म.
each prime number highest power.
हाँ भाई.
The for 2, what is the highest power?
2 to the power 5.
5. For 3, what is the highest power?
3 to the power 1.
Then 2 raised to the power 5 is 32, na?
हम्म.
32 into 3, it is 96. Remember, for LCM, always take the highest power. Don't think sir LCM means lowest common multiple, so I will take the less power.
Highest
15 minutes.
power.
Hmm. For SCF,
Lowest.
took the each
Lowest.
term lowest power. Then here 2, for 2, what is the lowest term?
2
What is the
square.
lowest of power? 2 square.
2 square.
For 3,
3 to the power 0. जो कि yeah.
okay.
हम्म.
This is how you find the LCM and HCF by prime factorization method. In prime factorization method, we convert the composite number as the product of a prime number. Then for LCM, you have to take each term highest exponent. For HCF, each term lowest exponent. Okay.
हाँ.
Same thing you do for 6 and 20. For 6, prime factorization. For 20, 2 3.
हम्म.
For 20,
2 into 2 into 5.
so I can write 6 as 2 into 3.
हम्म.
20 as 2 square
2 to
into
the
5.
power 2 into 5.
Look here. In both, here 3 is there, here 3 is missing.
हम्म.
So 3
3
raised
to
to
the
the
power 0.
here
And
in
5 to the power 0.
for LCM highest term.
LCM highest
For 2
term.
2 2 which is the highest
2 square.
exponent. For 3,
3 only. And
for
5 के लिए only 5.
HCF. What is the lowest exponent? 2.
and 3 to the power 0 and 5 to the power 0.
4 into 3 into 5. It's 60.
60.
Here 2.
2.
This is the HCF and LCM. Okay. You understand how to find?
Yes.
Okay. कोई सर କଥା ହେବି ଯେ ମୁଁ ମୋର ତଳକୁ ଓହ୍ଲେଇବିନି ଓହୋ ପ୍ଲିଜ ସଦି ସପ୍ତାହ ମୋର ଖାଇବା ପିଇବା ବ୍ୟବସ୍ଥା ତମର ରଖିଦେବ ଭାଇ ଅଛି ମାନେ ଭାଇ କରିଦେବ ଭାଇ ଯେ ନାହିଁ ବୁଝିପାରିଲି ହଁ ଠିକ ଅଛି
No.
wait sir ମୋର ସରିବ 7 suppose A and B are two number A and B are two number okay HCF of A comma B into LCM of A comma B okay is always equal to A into B. Remember the relationship between HCF and LCM. If A and B are two number, HCF of A comma B, LCM of A comma B, if I multiply, that result will be equal with the given number multiplication. Okay. Few seconds ago we are find the LCM of 6 comma 20. How much?
6,20.
Few seconds ago we find that 120. HCF is
HCF is
2. Now we find na few seconds ago. Then apply this.
2.
Then HCF of 6 comma 20 into LCM of 6 comma 20 should be equal to 16 to 2.
20.
So 16 to 20, 6 into 2 20. HCF is how much?
HCF is 2.
HCF is 2. LCM is how much? 60. 120. That means this rule is true now. You have to remember HCF of any number, any two number, any
HCF into LCM equal to product of
no HCF of two number. It is applicable for only two number. Okay, two number, two positive number. It is not applicable to more than two number. Okay. So you understand the relationship between HCF and LCM. Based on this concept, look example 3. Read the question.
Find the HCF of 96 and 404 by the prime factorization method. Hence find their LCM.
Find the HCF of 96 and 404. Two number are there, 96 and 404. By which method? Prime
Prime
factorization.
factorization.
Then 2, 2. It will be 48. It will be 40.
48.
Then again 24.
3, 24. हाँ.
Again
12,
12. 6. Again
6,
2,
3.
3. 3 2 ja 6, 2 ja 12, 2 ja 24, 2 ja 48, 2 ja 96. So I can write 96 as a
2 to the power 5 into 3.
for 404, 202,
202, 101,
101, and 101 is the prime number.
11.
Okay, it is prime. It is a prime
11
number.
से कट जाएगा.
Hmm?
11 से नहीं कटेगा.
किससे?
नहीं कट. नहीं कुछ.
You are converting the composite number as the product of a prime number. 101 is a prime number. Okay, so how it is divisible by any other number? Okay, so I can write as 2 raised to the power 2 into
2 into
101.
101.
Then which now? Here you look. 2, both the term are there na 2 2.
हाँ.
Here 3 available, here 3 is unavailable. So 3 raised to the power 0 into 101 raised to the power 0. It is telling you finding HCF. Finding HCF. For HCF, always took the lowest things, lowest exponent. 2 raised to the power 2
2 to the power 2.
into 1 1 into 1 1 1 1 1 1. Both the cases 1 1 because lowest you are taking na.
Hmm.
There HCF is 4. HCF is 4. Look,
4.
you can find LCM here, but we apply the second method for finding the LCM. Okay? Or here also you can find the LCM na. How you find LCM? Took the greatest one. 2 raised to the power 5. 2 raised to the power 5 into 3 into 101 into 101.
101 into 3.
So it will be 32 into 3 into 101. Then 32 into 3 3 1 ja 3 3 0 ja 3 3 3 1 ja 3.
3.
Then 32 into 303.
3.
303 into 32. 2 3 ja 6 0 6 3 3 ja 9 0 9 6 9 6 9.
9.
Look, your answer is HCF is 4, LCM is 9696. Look, 9696 na? Here we are trying to find, look, what is the formula? HCF of any number, HCF of 96 and 404. There are two methods for finding. One by prime factorization, here we are applying the formula into LCM of
96 and 404
96 and 404 equal to 96 into 404. HCF is how much? 4. LCM we are trying to find. Trying to find. Then LCM equal to 96 into 404
404 upon 4.
for 4. 96 into 101. At this 92, I can write 2 raised to the power 5 into 3, na? The same answer will become 9696. Okay? You understand? For saving your time in exam, you can apply this method. Okay? In this question, we are trying to find HCF LCM of a 3 number. Remember, it is a node point. that the HCF of a given two number into LCM of a given two number equal to the multiplication of a two number. It is applicable for only two number. Okay.
Two number
It is
and
not applicable for three number. So here you look. 6, 72, 120. Okay. I can 2 into 3. That means 6 equal to 2 into 3. 72, 72,
72 equals to
2,
2,
36,
36,
12,
2,
18,
12, 18,
2,
2,
9,
9,
3, 3,
3.
3. I can write 2 raised to the power 3 into 3 raised to the power
2
2.
to the power
3 into 3, 9, 9 to the 18, 18 to the 36, 120, 60,
hmm,
30,
30, 15,
15,
3,
3.
5, 5.
First check the missing number. 2, 2 in 3 cases 2 is there na?
Hmm.
In 3 cases 3 is there na?
3 is also there. 5 is not.
5 is missing. So write down 5 raised to the power 0. 5 raised to the power 0. I erasing this part. Look. For LCM. Took the each term highest power. 2 for 2, what is the highest power?
Highest power is 3.
2 raised to the power 3. For 3,
It is 2.
for 5, 5.
1.
HCF, not 1, 5.
5 to the power 1.
For HCF, what is the lowest exponent of 2? 2.
2.
3, 3. 5, 5 raised to the power 0.
0.
So 2 raised to the power 3, 8 into 9 into 5.
5.
Here it will be 6. 72 into 5. 5 2 ja 10, 5 7 ja 35, 36. 6 and 36. 360. LCM and HCF. Check once. 5 and 6 and 36. Are you looking?
Hmm.
Look. 6 and 330, 36. So try to apply that method. Okay. HCF of 6, 72, 120
120.
into LCM of 6, 72, 120 equal to A into V. Means 6 into 72 into 120. It will be how much? 6 into
70.
360, I think. 360 is the LCM now? Equal.
70, yeah.
LCM how much of 6, 7, 120? If you, 6 0 is 6, 6 6 is 36, 6 3 carry, 6 3 18, 18 3 21.
21.
Here 6 7 42. 42 into 120.
120.
Okay, 42 42 to 120. If you multiply 120 into 42. 2 0 is 2 0, 2 2 is 4, 2 1 is 2. 4 0 is 0, 4 2 is 8, 4 1 is 4. 0 4 8 2 is 10 5. Are these equal? So that means this formula is applicable for only two number, two positive integer, two positive integer. Okay.
Hmm.
Look, here is the remark. Look. Okay.
Hmm.
Then exercise 1.1. In this UT, how many chapter will come from math? Kita chapter
1 and 2.
1 and 2.
1 and 2. Hmm.
Look. Express each term as the product of prime factorization. You can able to do it.
Hmm.
Find LCM and HCF. You can also find LCM and HCF of the following integer by applying the prime factorization method. Okay. Given that HCF, yes, I can check whether 6 power n. Same question. Okay. What you should wrote? Any number. Hmm. Any number that can end with the digit 0 contain 2 and 5 their prime factor. But in 6 raised to the power n, but in 6 raised to the power n, whose prime factorization 3 into 2 raised to the power n, 2 is there as the product, but as the factor, but 5 is missing. Okay. Then these two questions try. If you are unable, then tomorrow we will do. Okay. Then revisiting irrational number, in which we prove why root 2 is a irrational number. Then we are proving why these numbers are irrational. Then we complete this chapter. I think then we complete this chapter. Okay. You understand how to find HCF LCM? Okay. During exam, don't do the silly mistakes. Okay. Try to understand. Okay. I'll upload this video. You can watch it or you can make your own note. Okay. Okay. That shall be removed from the class.